In this video I'm going to show you why I almost gave up this project, but how I came up with an idea that may just save the entire build. Hello everyone, welcome back. I built the cockpit of the Tomcat and I was pleased with the final result. When I wanted to continue the build, I realized that this kit had several problems. All of the sprues were offset molded, which requires a lot of extra work to fix. The problem with offset molded parts is that we lose a lot of valuable surfaces during sanding, which is very difficult to replace. I was close to the point of ultimately giving up this build and starting a new one. However, I prefer to finish models, so I thought about how to save this kit. The solution consisted of two parts. At a local air show, I was lucky enough to sit in the cockpit of the F-4 Phantom, which was just a cut-off nose section. In addition, I was in a museum where you could sit in an exhibited MiG-21. Okay, why shouldn't I combine the two ideas? A severed Tomcat nose section is on a display in a museum. For the first step, I built a nose section. I didn't modify or upgrade anything, I just put the parts together from the box. I had fitting issues, so filling and sanding were required. I used Tamiya grey putty and Mr. Dissolved putty. Then I used an ordinary needle and a 0.1mm saw to recreate all the sanded details. Because it's a museum display, I made a nice and clean paint job. After the primer, I did a very light pre-shading and then painted the final grey color. The pitot tube was useless in the kit, so I replaced it with copper tubes. I used the paper skim technique to paint the white wavy belly line. It gives a fine transition between the grey and the white. The Tomcat story started in 1968 after the F-111B project was cancelled because it had unmitigated weight growth, poor carrier suitability and no improvement over the F-4 Phantom. It could not overmaneuver the F-4 Phantom. Grumman learned many things from the F-111B project and they later used these experiences in the F-14 project. Anyhow, the Navy still needed a fighter to replace the aging Phantom. So with all this background, the VFX competition was launched in 1968. 5 large companies entered to the competition: General Dynamics, Grumman, Volt, McDonnell Douglas and North American Rockwell. 4 of these bids incorporated variable geometry wings. Grumman was selected for the contract award in early 1969 with the so-called 303E design. Originally it had a single vertical tail, but the Navy asked for double vertical tails for better stability, so Grumman changed the design. Grumman wanted to develop in 3 steps. Started with the F-14A, a new airframe, and used an existing engine and avionics inherited from the F-111. Later, the F-14B with a new engine, followed by the F-14C model with the upgraded avionics. In the end, I protected the whole paint job with a layer of clear coat. Though I didn't upgrade the kit, I added this extra detail to the launch bar. The launch bar is hydraulically lowered to hook the catapult shuttle on the deck. There were a couple of things what made the F-14 airframe so unique. The automatic computer-operated variable swept wings, the wing pivot selection, deflecting leading edge slots and flaps, glove vanes what gave more stability and maneuverability in high-speed, widely spaced engines, and weapon rails. Using Eduard's mask made the painting of the wheels easy. The resin wheels from Armory Models are much more detailed than the original, by the way, offset molded wheels. The wing pivot selection was critical in terms of minimalizing trim drag. Again, the engineers learned a lot from the F-111 project. As long as the F-111 pivot location was relatively inboard, approximately 1.5 meters from the center line, the F-14 pivot position was almost outboard, around 2.5 meters from the center line, resulting when it changed shape, less of the wing was actually sweeping, so the center of the pressure didn't move as much. It was a significant part of the building of the performance of the airframe. The decal sheet in the box was quite good, but it took a while to come off the backing paper. The decals were transparent, so I couldn't put the big insignia on a black and yellow stripe because the bottom decal came through the white star. Never mind, I applied a small insignia instead. I covered the stickers with a layer of matte varnish which gave a good basis for weathering. Next, I made a very light weathering, just a light touch of highly diluted Tamiya's panel liner. The fuselage was basically a lifting body. It produced around 40 to 60% of the aerodynamic lifting surface, depending on the wing's position. Around 40% of the plane was aluminum, and almost 25% was 6Al4V titanium. In the real world, these aircraft were extremely dirty. The paint faded and discolored, thanks to the salty air and the extreme circumstances during military service on an aircraft carrier. I usually dilute panel liners or make my weathering washes for myself. 2:1 ratio is what I like, but up to you. I prefer to build the weathered tone slowly, step by step. Honestly, I had no plans for the rear steel structure supporting the back of the nose, so I played by ear. I tried to figure out how such a task could be solved in the museum elegantly, cheaply, but definitely in a safe way. I used styrene rods in the size of 2 and 3 mm. If we do a simple calculation, 2 mm about 144 and 3 mm is about 216 mm in 172 reality. So a structure built from a 220 mm steel welded fitting is solid and heavy enough to provide reliable support to the nose. They used boron epoxy for the first time in the horizontal stabilizer, a long way from the center of the gravity. The Tomcat was designed fiber composite materials that were new in the aircraft industry. This method of use in this new material saved a lot of weight. I made the structure of the platform from a 1.5 mm styrene rods, while I used 1 by 4 mm styrene strips for the stairs, with 2 mm gaps between each step. To make the steps, first I set the metal ruler to the right angle on the cutting mat. The height difference between the top of the steps to the bottom was 30 mm. The horizontal guidelines on the cutting mat were solid reference to set the steps. I used a piece of 2 mm styrene to adjust the correct and even gap in between every step. After I finished the left side, I laid it down and glued the right side with Tamiya's extra thin glue. Again, I used that 2 mm styrene piece to adjust the steps. Then I glued the legs, the supports and the handrails in place. I wanted the stairs to look like they were out of wood. Oil paint is the best for imitating wood. For the first step, the surface must be primed. A white base is the best if you want a light wooden surface. If you want darker, I recommend mid-brown color for the base. Choosing the brown color of the wood is the matter of taste. I like the color yellow ochre. Apply your chosen color to the surface, then create the final texture with delicate long brush movements. The best thing about oil paint is that if you are not satisfied with the result, you can change and modify it for a very long time. That's what I did. I whipped off the whole thing because I didn't like it. Then I repainted it. So I didn't like it. It was too dark and thick, and I wouldn't say I liked the tone either. So I whipped it out. The cleared surface remained a very light yellowish brownish base. Then I made the yellow ochre thinner and repainted the whole surface. I left the painted parts to dry for a week or so. Then I applied a layer of matte varnish. There was a titanium wing center section box which was the heart and the soul of the airframe. Approximately 6.7 meters long and it weighed about 900 kilograms. It was almost 2/3 of the weight of the traditional bolted steel box. It was welded in the vacuum chamber. It was probably one of the most unique things at the time in aviation, but the Navy didn't like it. The Navy didn't like welded primary structures because of maintenance reasons. They wanted a bolted design. So because of this, Grumman tested these boxes at 115% limit low to prove the Navy this design is solid, and it worked very well. When they added these design elements all together, the F-14 in terms of its primary structure was around 450 kilograms lighter than the F-111B, so naturally it was a big deal. The canopy in the kit is pretty thick and distorted, and there is an ugly seam line at the top. So I scraped it back with a sharp fresh blade and sanded it with 600, 800 and finally a 1200 sandpaper. For the final sanding, I used sanding sponges from 2000 to 10,000. Finally, I polished the prepared surface with Tamiya's polishing compound in 3 steps. Eduard's masking sheet was pretty helpful, but there were a couple of size issues that I had to fix. By the way, this is not a too complex canopy shape, so if you have a thin, good quality masking tape, you can do the job without a pre-cut masking sheet. But definitely Eduard's sheet made the process quicker. The kit also includes a PE sheet. However, I just used a couple of parts of it. It's a nice extra in the box. The metal sheet was surprisingly thick. I couldn't cut it with a hobby knife. I used only the frame hooks on the inside of the canopy and the mirrors. The air conditioning pipes are 0.4mm lead wires. The small mirrors are very nice details. Before I painted black, I prepared the metal surface with Mr. Metal Primer. I saw a couple of photos where the hooks inside the canopy were painted in a light grey. I don't know what the reason behind it, but it looks cool, so I did the same. I used superglue to glue the rear support structure to the fuselage, but before that, I properly cleaned the surface to create a strong bond. The F-14 was designed around the Phoenix missile and the AWG-9 radar. This radar could track 24 targets at almost 400 kilometers and launch 6 Phoenix simultaneously. The inbuilt weapon the Tomcat could rely on was the 6-barrel 20mm GE M61A1 Vulcan, located in the left side of the nose roughly under the pilot. It was a very high-power gun. It could fire 6,000 rounds per minute. The large 676-round drum cylinder was located under the back seat. The Tomcat also could carry sidewinders for short-range targets and sparrows for mid-range targets. Later versions carry various types of bombs and laser-guided bombs. I used a styrene sheet for the concrete floor and gently scratched the structure joint imitations. After the primer, I painted the whole thing sky grey, then painted the yellow and the black stripes. Finally, I lightly weathered it to make the surface more interesting. Again, it is a museum, so probably it's super clean everything. That's why I used light post shading and weathering. I wanted to make the diorama a more interesting exhibition piece, and I came up with an idea of placing one of the vertical fins on a small wheeled base. In addition, the Jolly Roger's VF84 emblem is spectacular, so I wanted to use it. First, I prepared the base with grey primer, then I painted the yellow and the black paint. The decal is not very thin and stands out from the surface, so I had to fix this. After the decal was dry, I applied 3 layers of glossy varnish and let it dry completely for a day. Next, I sanded the edges step by step with fine sanding sponges. It must be sanded until the shiny line disappears at the edge of the decal. Finally, I unified the whole surface with a layer of matte varnish. The wheeled base is made of styrene pieces. The only engine available at that time for this project was the Pratt & Whitney TF30. This engine was a low bypass turbofan engine designed for the subsonic F-6D Missileer airplane. That project was cancelled. Later, Pratt & Whitney updated with an afterburner. Basically, it was the first afterburning turbofan engine. It was a bomber engine with no variable geometry and no electronic control. This engine was inherited from the F-111B project, but there was no other option. The TF-30 wasn't the best engine Grumman could have hoped. The TF-13 caused nearly 30% of all F-14 crashes. It was underpowered and couldn't easily handle disturbed airflow in its air intake, leading to compressor stalls and suddenly loss of thrust. In 1982, the TF-30 was upgraded to improve its reliability and durability. In 1987, the General Electric F-110 engine was finally introduced in the F-14B model. With this new engine, the Tomcat became the ultimate fighter airplane it should have been. This new engine was reliable and enabled the pilot to slam the throttle to military power from idle and back at will. I cut out small styrene discs and used a 0.9mm alloy tubes for the cordon posts. Oh, by the way, this is Bob. Bob was helpful as I used him as a reference. I covered the holes at the top of the tube with Mr. Dissolved putty. I drilled 0.3mm holes at the tip, then I put a 0.3mm copper wire in it to make some hooks to attach the cordon chain. Then I painted them shiny aluminum metal color. I used just a tiny drop of superglue to fix the elements on the base. The chain I used is too thick, as it is 1mm, so it's 72mm in a 172 world, which is quite large, but I couldn't find a finer one. It's okay, let's just say it was a chunky chain. I think that the Tomcat stood out among the fighters of its time with its design and most of all with its performance. Definitely one of the most iconic jets from this period. Maybe even the MiG-21, which is for me is another iconic fighter from this era. But that might be a topic for another video. If you want to add thoughts to the comment section, please feel free to do so. Maybe I was unlucky with this kit, but that's probably why I was able to create something that I didn't even think about when I bought this model at the local hobby store. I hope you like this build, and see you next time.